Hello everyone, presenting a discussion on the Oroville Dam crisis by Group 53 of Engineering in Society course. We are going to discover shocking truth behind this accident. Located in Northern California, Oroville Dam is the tallest dam in the United States at 770 feet. Completed in 1968, it became a crucial part of California's water system, providing power, flood control, irrigation, and water to over 27 million people. However, hidden problems existed from the start. Cracks, seepage, and erosion beneath the main spillways were treated as routine maintenance only. Structural issues were underestimated, left the dam vulnerable. In February 2017, extreme rainfall caused excessive water flows, turning the minor flaws into a major structural failure. A large section of the main spillway collapsed, and rapid erosion of the emergency spillway forced nearly 188,000 people to evacuate. Now, let's dive into the technical and engineering issue behind this accident.
So let's break down the key technical failures. The first one is main spillway failures. So on February 7th, a massive crater formed in the main spillway. This happened because the concrete slabs, already cracked due to aging and poor drainage, allowed the water to seep underneath. As the water flowed with high velocity, it created uplift pressure beneath the slabs, and with no effective under-drain system and poor anchoring, the slabs were lifted and washed away. This exposed weak rock underneath, triggering aggressive erosion known as head cutting, which rapidly worked its way uphill towards the gates. The second one is emergency spillway flows. So we can see how the emergency spillway, which had never been used before, was activated on February 11th. Unfortunately, it was simply an unlined hillside with a 30-foot concrete weir, with no erosion protection. As the water overtopped the hill, the soil and rock eroded much faster than expected, threatening to undermine the weir itself. This posed a serious risk of uncontrolled water release. The third one is monitoring and risk management gaps. Despite the decades of warning signs like cracks and seepage, the dam had no advanced instrumentation in place. There were no sensors to detect the subsurface erosion or pressure changes under the spillway. Maintenance was reactive, not risk-based, and the previous upgrade proposal, like 100 million plan to line the emergency spillway with concrete, were rejected in 2005. Had proactive risk assessment and real-time monitoring system been in place, the situation could have been detected and mitigated much earlier.
Now, I will explain some of the ethical reasons behind the Oroville Dam failure, focusing on three key points, namely negligence in maintenance and inspection, poor communication and risk transparency, as well as complacent organizational structure. First, warning signs were seen as early as the 1960s. Cracks formed in the main spillway shortly after construction, and unusual water flows were reported from the drainage pipes. These signs showed that the concrete and foundation might be weakening, but instead of investigating further, the issues were considered as normal and were simply patched. No proper structural review were made, even though these problems keep happening over the years. This shows a failure to act on important safety concerns. Second, the organization responsible, the California Department of Water Resources, developed a complacent culture. Because the dam has worked for decades, the team has become overconfident and believed that no major upgrades were needed. They did not encourage outside opinions or the internal reviews. As a result, they relied too much on old methods and assumptions, even as the structure aged and conditions changed. Finally, during the crisis in 2017, there were major failures in communication. Civil and geological experts warned that using the emergency spillway was risky due to erosion, but their advice was not taken seriously. There was no clear coordination between the teams, and the decisions were made without fully understanding the risk. This delay in action led to dangerous erosion and forced a massive evacuation of around 188,000 people. In short, the Oroville Dam crisis was not just an engineering failure, it was also an ethical failure caused by ignoring warnings, overconfidence in the system, and poor communication during the critical time.
For future recommendation to prevent disasters like Oroville Dam failure from happening again, several key steps must be taken. First, we need smart monitoring systems. These use sensors to track internal damage like cracks and water seepage in real time, alerting engineers before the problems grows worse. Next, using stronger materials like ultra high performance concrete or UHPC makes the structure more durable and water resistant. It's also crucial to require third party structural reviews for all major dam projects, ensuring that no critical flaws are overlooked. On the organizational side, forming a joint emergency coordination committee helps agencies respond quickly and effectively during crisis. And finally, with climate change causing more intense storms, hydrological models need to be updated regularly. By combining advanced energy, stronger materials, better oversight, and climate adaptation, we can build safer and more resilient dam systems for the future.
To conclude this report on the Oroville Dam crisis, it is important to understand that the disaster was not just a result of one mistake. It was caused by a combination of engineering, ethical, and institutional failures. This case shows that simply following regulations is not enough. Engineers and decision makers must also think ahead, question old assumptions, and act with ethical responsibility. In summary, the Oroville Dam incident reminds us that safety, ethics, and accountability must always be central in managing critical infrastructure. With that, I end this presentation. Thank you.